Arweave introduced a new approach to decentralized storage, designed to create a permanent and collectively owned archive of knowledge. The project is built around the concept of the Permaweb, a web of data and applications that live forever, accessible to anyone without centralized control. While most blockchains store transactions, Arweave's system is optimized for permanent data storage using an incentive structure that ensures information remains available indefinitely. At the heart of Arweave is the Blockweave, a data structure similar to a blockchain but designed for scalability and permanence. Each new block links not only to the previous one but also to a randomly selected earlier block. This mechanism, known as proof of access, requires miners to show they can retrieve data from a prior block to produce new ones. In doing so, the network ties mining rewards directly to the act of preserving old information. The result is a system where storage and consensus reinforce each other, ensuring that data integrity and network security grow together. Arweave's proof of access replaces traditional proof of work or proof of stake mechanisms with an approach that rewards those who store data. To participate, miners must prove they still have access to historical blocks. This creates a direct financial incentive to maintain long-term storage, since a miner's ability to earn depends on their contribution to the collective memory of the network. It's a design that turns the task of archiving into the very foundation of consensus. The network is powered by the AR token. Users pay a one-time fee to store their data permanently, and the payment is distributed among miners over time. A portion of each fee is placed into an endowment fund that continues to reward miners as storage technology becomes cheaper. As the cost of storage decreases, the endowment can fund the network for longer, theoretically guaranteeing perpetual storage from a single payment. This structure removes the need for ongoing subscriptions or maintenance costs, setting Arweave apart from both centralized and decentralized storage models. Arweave extends beyond raw storage through the Permaweb, a layer of permanent websites, applications, and records that live on top of the Blockweave. Each page, article, or application is cryptographically verified and immutable once uploaded. Developers can build censorship-resistant apps, publishers can create archives that cannot be edited, and users can access content that will remain online forever. The Permaweb functions as a permanent layer of the internet, version-controlled, transparent, and owned collectively by its users. This focus on permanence has broad implications for data integrity and history. In an online world where content can be deleted or rewritten, Arweave preserves verifiable information that cannot be erased. Journalists can secure reports, researchers can archive datasets, and developers can rely on an unchangeable infrastructure. By guaranteeing that information persists, Arweave becomes a tool for preserving truth in the digital age. The protocol is designed for accessibility as well as decentralization. Through browser-based gateways, users can access Arweave data as easily as any website, while developers can integrate Arweave's APIs into traditional web frameworks. This combination of permanence and usability makes the system practical without compromising its decentralized design. A growing ecosystem of tools, including ArDrive for file storage, Mirror for decentralized publishing, and KYVE for data archiving, demonstrates Arweave's reach beyond simple storage toward full-scale Web3 infrastructure. Arweave's efficiency lies in partial data replication. Instead of requiring every node to hold the full dataset, miners store overlapping subsets verified through cryptographic proofs. This structure balances redundancy with efficiency. Enough copies exist to ensure resilience, but not so many that storage becomes wasteful. Even if nodes disappear, data can be reconstructed from those that remain. Economically, Arweave introduces a new kind of digital ownership. Traditional cloud services rely on recurring payments, but Arweave compresses cost into a single transaction that secures storage forever. Information becomes an owned asset, immutable, transferable, and self-sustaining. This aligns with the broader principles of Web3, where users control their data and infrastructure functions without intermediaries. Since its mainnet launch in 2018, Arweave has evolved into a cornerstone of decentralized infrastructure. It now supports millions of permanent files and applications, powering a new model of internet permanence. While questions remain about long-term incentives and storage economics, the system's endowment-based design and active ecosystem have proven resilient and scalable. By combining cryptographic verification, sustainable economics, and collective participation, Arweave redefines how data exists online. It transforms the web from a temporary medium into a permanent, verifiable record of human knowledge. For more insights on Arweave, decentralized storage, and the evolution of the Permaweb, remember to like, subscribe, and keep learning, here at Crypto in Black and White.